IP version 4 networking. In this nugget, we take a look at IP version 4 networking, where we start off by taking a look at IP addressing fundamentals. It's important to understand how an IP address is comprised of the various bits that it's composed of. So we'll take a look at that and understand some things about subnetting and the like. Then we'll take a look at how to configure the appropriate network settings. This is going to play a lot into the exam objectives for connecting to a network and setting up a connection to a network. Then we'll take a look at the network locations, such as public or home or work. We'll take a look at the new home group feature of Windows 7, which makes things an awful lot easier to share resources in Windows 7 than we have in previous versions. We also take a look at name resolution, because computers don't actually communicate by name to one another. It's actually by IP address on an IP network. And then we'll take a look also at troubleshooting. Because IP networks do have problems from time to time and need to be able to trace down where the problem is coming from. Alright, as we get started here, I've created a document. It's called decimal to binary.pdf. It's available for you up on nuggetlab.com, along with all the other files from this series. Now, I've kind of put this down to the bottom of the screen here. It looks a little awkward the way it is right now, because I'm kind of reveal some things as we go, as I move the screen up. First of all, though, we need to understand how IP addresses really are numbered. And in order to understand that, we have to get around some kind of paradigm shifts that we have as humans, because humans have a tendency to see things in decimal numbers like we have right down here. So here, if we had this IP address, I might ask you, how many numbers is that? And most people would say, okay, there's 223, 120, 172, 16, 30. Okay, there's 4 numbers there, right? Not actually. In binary is how this actually appears to the computer, and the computer is actually going to see a single number right there. All right. The only reason why it's broken up into these decimal equivalents is for us weak-minded humans that go cross-eyed trying to read the binary equivalents like you see right there. Okay, this is how the computer would see it, more or less. The only difference is I've put the periods or the decimal points in here so that you can kind of break it up a little bit. It's just hard to read if it's a continuous string of zeros and ones. But subtracting those, that's how your computer would actually see this. And that's how we need to understand numbering in IP addressing in order to really properly work with them. Now, I'm probably going to overshare, as usual. I'm probably going to share more than you really need to know for exam purposes here. However, I think it's just good information that most administrators will need to have some familiarity with. I don't think you're going to need to memorize absolutely everything I'm showing you, and you may not even be able to work with these subnets and custom subnet masking and all of these types of things that I'm going to talk about with great expertise. But at least if you understand the concept and how they're done, then I think you'll be doing just fine in terms of preparing yourself for the exam and at least developing a level of competency on a Windows network. So then, having dragged this up here, let's translate all of this so that we can understand why the computer sees 223 as that series of zeros and ones. One of the first things to understand is that these are not literal zeros and ones. You don't do it like this, the 1 plus a 1 plus a 1, that's 3 total ones, that'd be a total of 3, 4, 5, 6, 7. No, you don't add up ones here. What these zeros and ones all represent is not the literal decimal one, they're on, off, or enabled, disabled, true, false. That's how binary is. It's either all on or all off. There's no gray area. So what it's saying here is, in this 8-bit position, these are all known as bits, the first bit right here on this side right here is turned on. So is the second one. So is the third one. So are all of these rightmost bits that we see right here. And then these two on the end are also on. The only one that's off is this 0 that you see right there. So when you convert that to a binary kind of a numbering line, what we have here is in each one of those bit positions, like starting with this one right here, that represents the position of the number 1. The second one right here represents the position of number 2, and 4, and 8, and 16. My mouse keeps selecting too much, I'm sorry. And 16, and so on. So the way we would actually work with this is we would take each one of the bit positions that is turned on, 1, 2, 4, 8, 16, 64, and 128, and you add up all those numbers together. Here, let's go ahead and take a look at the calculator. Okay, I'm just going to crack this open, and in Windows 7, we have a new view of the calculator. In order to work with binary like we're doing here, you'll want to go to the programmer view. In previous Windows, you would go to scientific, but not now. So let me move this around here. I'm trying to get it in a place where we can see all this in the background. I don't think we have enough room, but let's just give it a shot here. So we want to add this all up. We would add 1 plus 2 plus 4 plus 8. So let's start with that. 1 plus 2 plus 4 plus 8. Then what else have we got? We got 16. Okay, there's 16. So we go plus 16 plus 64 plus 128 equals 223, as you can see right here. Okay. So another way to confirm that would be if I were to go to the binary. You see the binary radio button there. Then it would give me 1101, 1101, and then a 1111. Okay, 1111. All right. It puts a separator in here to make it a little bit easier to read, but we can confirm that our math is correct, at least using this method here. So that's the way all that maps out, and you can take a look at these others, and they're all mapped out the same exact way. And then as I scroll down here, another part of this that's important to understand is something called the subnet mask. The purpose of a subnet mask is so that when your computer tries to communicate with another host on the network, it's able to distinguish whether or not that host is on its own network or on some other network, and then it would need to go through a router or your default gateway, as it's called in Windows. Okay? So that's the whole purpose of the subnet mask, and you have to have those. Here we have a subnet mask, and it's identified by what we call slash notation or CIDR notation, which is CIDR, classless interdomain routing. You don't have to memorize that. I'm just pointing out that that's the way this is called, is when you write it out like that. Most of the time, you're going to see probably the subnet mask identified more like this, so that you'll have an IP address of 223.172.16.2 with a subnet mask of 255.255.255.0. But when we shorthand this, which is what we often do, we'll just tell it how many bits in the subnet mask are turned on. And if you look at our bits down here, there's 8 plus 8 is 16, plus 8 more is 24. Okay? And when you add all of those up in each octet, that adds up to 255 right here. This adds up to 255 in the middle. Okay? And the same we have right here. And then this adds up to 255, and that's what we have right here. Okay? So that's how we get that equivalency. All right? And then understanding this in relation to how it will identify whether you need to go through a router or not is something that uses the ANDing process. It's called ANDing. Okay? It's kind of a weird name, I know. But what happens here is it has to combine this subnet mask in binary with the IP address that we see right here. So that if this host right here on this IP address and subnet mask wanted to send a message to this IP address and subnet mask, then it would be able to identify whether or not it has to go through a router by using ANDing. And the way it does that is it will combine these two lines together. And anytime you have a 0 plus a 0, it equals a 0. Anytime you have a 1 plus a 0, that also equals a 0. So for example, here we have a 1, and this is 0, that equals a 0. Here we have a 1 and a 1. What does that equal? Anytime you have a 1 and a 1, it equals a 1. Okay? Now remember, when you were in first grade, you learned that 1 plus 1 equals 2, but we're not talking about decimal numbers here. All we're saying is this is on, and this is on, so it's left on. That's another way of looking at that, okay? But anytime you have a 0 involved, it always winds up being a 0. Now, when it combines, when your TCP/IP stack combines the IP address plus your subnet mask here, then the only place where it has a 1 and a 1 that are next to each other, like this 1 and this 1, then it will give me a 1 down here. And you can see there's some other ones as well. Now this is the ANDing result. And when it tries to communicate with this host, it will take this IP address, which is now in binary here. It runs it through the subnet mask that it uses here, that this host is using, and it sees that the ANDing result, if you look at all the zeros and ones, is exactly the same. All right? And if it's exactly the same, it knows that it does not have to go to my router or default gateway. And again, those are the same thing. Now let's take a look at this one. Look at this one. This guy's on a different address. He's on 223.172.17.254. So what do we do with this ANDing? Well, here we have this subnet mask, okay? And again, the subnet mask that we use for the ending process is the subnet mask that's used on the source computer. On my computer, for example, if this is where I am, I'm using my subnet mask to try to reach this host and to do the ending process. So when I take that destination's IP address and I run it through my subnet mask, this is my ending result. Now, especially look at this last octet. And we call these octets because they use 8 bits. Okay, oct meaning 8. When we look at this last octet, is this the same as my own ending result in the last octet? No. I mean, this one is the same, right? I can't get this mouse to work. There we go. Right there. But this one also, down at the bottom, this one also adds this one. So since the ending result is not the same exactly, then when this host communicates with this one, then it knows that it has to send the message or the packet through my router. And then the router will be responsible for determining the best way to send the traffic to get to the proper destination. Now then, I have another document here, and this again is more information that I think you really need for the exam, but it's called Creating Custom Subnet Masks. You see, we were using classful subnet masking, which is where you, for example, we use a class C address, which is using the 24 bits, like we were showing you earlier. However, sometimes you need to chop that subnet mask up into smaller or larger parts, because you might have the need to use more hosts on a subnet than you would have with the default length of a subnet mask. Or you need to have more networks than you would normally have. So in order to do that, you manipulate the subnet mask so that it does what you want it to do. All right. Now, I'm not going to go through all of this here. I'm just pointing out that this is available for you up on nuggetlab.com, and if you follow this closely, you'll figure out how to do the creation of custom subnet masking. And I think it's pretty well explained and clear for you, so I think you'll be able to get this if you just read through it carefully. However, one thing that you should definitely know is the default IP address classes. Okay, there's several different classes. The first one is a class A, and then the second one is class B, and the third one is a class C. Probably class C is one of the more frequently used ones in local area networks. So that's an example of the one that I used for you there. And that's where we used the default subnet mask. This is a 24-bit subnet mask of 255.255.255.0. 24 bits. Okay. With these different address classes, you can have varying levels of networks and hosts. All right. So with this kind of a subnet mask, I've got a subnet mask of 255. That means that everything where there's a 0 can be used for assigning host IP addresses. Well, that's 24 bits there. Okay, so that's quite a lot in terms of total mathematics. That actually adds up to 16 million hosts. Now, of course, you're not going to have that many hosts on a single subnet. So that's where organizations will use custom subnet masking, like I was talking about a moment ago, to split this up into smaller pieces. In fact, that's what I've done, because if we go to an IP config at a command prompt, then what you'll see here is, let me just actually open one up. What you'll see here is, if I do an IP config, then we can see that I'm using a class A subnet. Okay, it's a 10 dot network. All right, just like we have the class A up here. It's the network ID. Anything between A1 and 126 is in the class A. So this is class A. But I don't have and I don't need 16 million hosts in my network. Okay, so what I did was I just used a class C subnet mask, and that way, with even using a class A network, using a class C subnet mask, I get 256 hosts in my network. All right. Now, other things to look at here as you go on through is that you have what we know as a class A loopback address, and this is 127.0.0.1. We'll talk more about this maybe when we talk about pinging later on as a diagnostic tool. But sometimes if you're having trouble with connectivity, if you want to confirm that your TCP/IP stack is loaded properly in Windows, then you can ping that IP address, and if you get a reply, then the IP stack is loaded properly. If you don't, then there's something wrong with the IP stack. It might be corrupted or having some other kind of problems, and you may need to restart the computer. Or there may be a problem with something like that. Also, the private IP addresses. Remember I told you earlier I was using a 10 dot network? Well, these are private IP address classes that you can use in the corporation, for example, or in home networks that are not routable on the internet, and they are not directly attackable from the internet either. There are other methods that you can use kind of indirectly, but they're not visible directly on the public internet, so it adds a little bit of a level of security. Almost any home network you see will probably be in the 192.168 range, although I use a different one for my own network. I use the 10 dot. And for many corporations, you'll see anything in this whole range being used. All right? And then there's also something called a PIPA, or automatic private IP addresses, which would be a Class C address in the 169.254.0.0 range, and we'll take a look a little bit more at that a little bit later on here. But this again is another document that's available for you. It's called addresses.pdf, and it's part of the zip file also available for you up on nuggetlab.com. Now that we have some understanding of IP addressing, let's address how to configure the network interface. Here you can see the little tray area. There's this symbol for the network, so I'm going to right-click on this and choose Open Network and Sharing Center, which I could have also done by going through Control Panel. It's just a little bit more direct here. And then I want to go to Change Adapter Settings. Having gone into this, I want to right-click on the network adapter, local area connection, choose Properties as an administrator, which means that I can make changes to this if I want to. These are all default things. I haven't really changed anything in any of this. But let me explain what some of the things are that we can see here. One of those would be Client for Microsoft Networks. What is that about? This allows me to look for resources that are shared out there on the network. In other words, I am a client for shares that are out there. Quality of Service Packet Scheduler will help to prioritize rate of flow for things such as video conferencing, other things that need to have a higher priority. And because of that, I might have fewer skips and pauses and things like that in live video. Printer and sharing, file and printer sharing for Microsoft Networks allows me to share resources on this computer so that other people can find them. Then there's TCP/IP version 6, which we'll also address in this series in brief, but that just means that I'm enabling it here as well. And then TCP/IP4, of course, is what we're about to discuss in more detail in a moment. But these two down here also relate to being able to identify other resources on the network. It goes a step beyond the client for Microsoft Networks. In other words, this is really mostly just for finding shares. This also will help to map out the network as well as network devices, and this is associated with that as well. It allows this computer to be part of the discovery in all of that. Now, let's go ahead and take a look at TCP/IP version 4 up here, and I can double-click on it or choose Properties. Either one works. And this is where we would make changes to our IP configuration. By default, we obtain an IP address automatically, meaning that it's going to use a DHCP server to issue an address to me. And we also obtain the DNS server address automatically, which actually also comes from the DHCP server. But these things can be configured manually. We don't normally do that on a lot of workstations. Normally that's going to be done on servers, IP printers, things like this. But in some organizations, they require a static address, which is where you configure all this manually, same as a static address. Now, how do I know what to type in there? That's where we're going to go to take a look at something like this. See, you don't know what to type in there until you're first understanding a little bit more about your network topology, where your routers are, and so forth. So if this is my client right down here, then I need to know what subnet I'm on. You can see here that this client is on the 192.168.1.0 24-bit subnet mask, so it's on a Class C network, if you remember the table that I showed you earlier here. Now, as a result of that, when it connects to my router here, and this could be a Windows Server 2008 router, which could be acting as an ISA server which performs routing for us, or if you want to change this, this could be a hardware router, like something from Cisco or some other networking company. All right? But these routers will have more than one interface on them. They'll usually have at least two or more. So the interface is another way of describing the network card in this case. And this router's IP address for the network card on this network is 192.168.1.1. And very often for network topologies, the routers will be the lowest available numbers or maybe the highest available numbers so that they can be distinguished from other hosts on the network. So it could also possibly have been .1.254, for example. But if I'm trying to communicate on this host with this file server and download some files from it or open some files, well, it's on 10.10.10.80, which is, you can tell just by looking, that it's a totally different network than the one I'm on over here. So, how do I know what to enter in, for example, for my IP address? Well, since I'm in this network, I need to enter in an IP address that's in that same family, so to speak, of network address, and one that will wind up with the same ANDing result as any other computers that I have in this network. That way, if it needs to communicate with a server here that's also on the same network, then when it ANDs the result, does ANDing, then it knows that it doesn't have to go through my router. It can communicate directly with that destination host. But when it tries to communicate with some other host on a different network, like this other one in my own corporation, but on a different subnet, or this public internet web server, then the ANDing result is going to show that it has to go to a different network. So for that, I need to know what my default gateway IP address is. And then when we actually do the configuration for this, it'll look something like this. So if we use the same scenario there in our addressing, then this host would be 192.168.1.100. And again, most of the time we use DHCP for this, but sometimes you'll have servers and some clients that you need to enter in static addresses for, like we're doing here. Also, the subnet mask will automatically be calculated as this class C24-bit subnet mask. However, if you are doing custom subnet masking, then you could change that to something else. Then there's the default gateway. Now, this is where I was saying earlier, I need to know what my default gateway is here. It's 192.168.1.1. So I'll enter that in here, 192.168.1.1. And then I would also have to know my DNS server addresses. And I don't really have that pictured in here, but let's just say that, for example, this is a file server and a DNS server. Okay, then that would be 10.10.10.80. All right, and then so I would go into this and I would enter in its IP address as 10.10.10.10.80. And there we go. If I have another DNS server that I could use as a backup in case this one is offline for some reason, then I could enter that in here as well. 10.10. Let's say 20.50, something like that. And then we would be able to click OK. Now, something that's new with Windows 7 is that it adds this checkbox to validate settings upon exit, which would fail in my case because I don't actually have any of these servers. I'm all on different subnets and so forth. But if everything were entered in properly, it would validate them and we would be fine on exit. Otherwise, it'll pause and identify that there is a problem there for you. And then just briefly here, I'm going to go to a DHCP server. Now, the point of a DHCP server is to automatically fill in all of those things that we just filled in manually for a static address. This will do it for us, and it's very useful for your clients, especially if you have dozens, hundreds, thousands of clients where you just can't sit down on each desktop and fill all that stuff in. Also, static addresses are usually more important on devices that you need to always have be the same address, like your file server. You probably always want that to have the same exact IP address. That way it would be easier to troubleshoot and track down at later points in time if you needed to. But for generic network clients like Windows 7 computers, I really don't care what their IP address is, just as long as they get one. So here we would have a scope that we would configure, and then we would have an address pool that we would configure. And you can see here that the address pool that I've configured here is 10.10.10.20 through 254. And the first few addresses, 1 through 19, are reserved for other things, other kinds of devices like servers and printers and the like. Any address leases that I have given out will be given here. So these have all been leased out to clients out there on the network right now. And then if I have any reservations, I can configure those as well. What this means is that when these clients come up, for example, this laptop computer, whenever it comes up, I always want it to get 10.10.10.35. What I'll do is I will associate a reservation with a MAC address. So if I right-click to choose a new reservation, and I'll just say, James, desktop, or whatever it is, then I always want that to have the IP address of 10.10.10. Let's say 190. And then what I would do is I'd also have to know its MAC address. And then I would enter that in here as well. And I really don't have one off the top of my head, but let's just say that it's MC, whatever. You just enter in whatever the MAC address is. By the way, how do you find out the MAC address? Well, just quickly here, I'm going to go to the command prompt and do an IP config all. And when you do that, it shows you the MAC address of all of your network adapters. So, for example, for this one, my MAC address is right here. So if I were to press Enter to put that in my clipboard, then I could just paste that in right like that. Okay, and so that's the way this would work. And then you can identify whether you're going to use DHCP or BootP. I'll talk a little bit more about those here in a little while. But these are methods that are used to get you to a DHCP server, especially if it's on a different subnet than the one you're on right now. Also, there's scope options. This is where we get the DNS server. Remember I said earlier that the DNS server can be automatically configured? Well, that's because I've got it configured in here so that when my clients try to get their DHCP server settings, then they're going to be configured through these scope options. So if I right-click here and choose Configure Options, then I scroll on down to find my DNS servers here, then I can add in DNS server IP addresses, whatever they are, 10.10.10.3 or something like that, and add those in. They may also be configured through server options, but that's a little bit of a different level of scope than what we need to do right now. Just understand that they can get their IP address, their configuration, their router address. All of that can come through the DHCP server, preventing me from having to do any of that stuff on my own. Now let's go ahead and take a look also here at something called network locations. Once your client gets on the network, whether it's used a static address or a DHCP assigned address, it needs to be able to get an identity here. Okay, so it needs to know whether it's on a public or a private network. And the way this happens is that as soon as the connection is made, Windows will prompt you with the following dialog box, and you'll need to make a decision as to which one you're on. Now, these are made in or described in very user-friendly ways so that those who are not technical can probably make the right decision. So that if they're in the airport or a public library, a coffee house, they'll probably choose public network. At least I hope so. If they're at a work network, then they'll probably choose work network. Now, for the domain, Active Directory domain computers, they will not receive this prompt. They will automatically be put into another one that does not appear here, known as the domain network. And I'll describe all these as we go here in a moment. There's also the home network, which hopefully they'll understand that if they're at home, that's the one they're going to choose. Now, why does Microsoft want you to make these decisions? And the reason for that is because based upon which one you select, it's going to change your security level. If I'm in a public place and I make that decision, then I'm going to have discovery and sharing turned off. Discovery is where I can find out on the network other resources, so that I could double-click my way through network neighborhood, and I could potentially map out network devices that are out there, shared devices and shared printers and so forth. So those things are going to be turned off in terms of the discovery, so I can't see those resources out there. Likewise, my own sharing is turned off, so that people will not be able to double-click their way through a network and find my resources. Now, this is somewhat secure, but obviously, a determined hacker with the right tools will still be able to find you and probe your resources and things like this. The other thing I could choose here would be a work environment, which would put me actually in the private network location. This is also known as Network Location Awareness, or NLA. And this would turn on discovery and sharing so that I could find resources on the network that are shared out to me. And likewise, if I had shared resources that I wanted other people to be able to find, they could find me as well. Similarly, if you choose home, that also puts you in private. These are actually the same exact thing. It's just that in the interface, it makes it look as if they're two different things. They're actually both the same. Both of these will actually put you into the private network. Okay. Now, once you have made that decision for the home, again, you're going to be put into the appropriate location, as you can see here. Discovery and sharing will be turned on. And then the one that I said is not on there is the domain. If it identifies that your computer has authenticated to a domain controller and you're on a domain subnet, then it will automatically just put you into the domain network. And this will also be the same setting. It's all private. And again, discovery and sharing will be turned on and available. Now, with Windows 7, there's also something else here that's new, and that is something called the home group. This is something where in organizations like domains, you would have all the computers belong to a domain, and it would make them easier to share and find resources and to authenticate against one another and so forth. Well, for the home, it's not always been quite that easy. So what happens here is, as long as you choose the network location awareness setting to be the home environment, then what will happen is it'll make it very easy to do file and printer sharing. This only works with Windows 7 across all editions. However, if you're working with the Starter Edition or Home Basic, you can't create the home group, but you can find resources in an existing home group. So for example, here on this computer, which is not a member of my domain, it's just a work group computer, notice that I'm on the home network here. By the way, if you ever need to change any of these, you can click on that link and then pick one of the other selections. But I'm going to go ahead and cancel out of that and choose home group and sharing options. And from this point, there is no home group yet. So what I would have to do is to create a home group and specify the kinds of things that I want to share. If I have printers, pictures, music, whatever it is, I can share those things and click on next. And then it would make this available to the rest of the network to find in this home group. Notice here that it does identify a password that I'll have to enter in, and I'm just going to copy this in case I need it, that I would have to enter in when I add additional computers to the home group. After all, a home group is not much use with a single computer because you just access whatever you need locally. It's when I have a network and I have one or two or more computers across the network that need to access each other's resources. And then I'll need this password in order to add those additional computers. And then once you OK past that, you'll see that you can again go back and make changes. If you didn't mean to select music, you could deselect that, for example. You can also stream pictures, music, and videos over the network. By the way, these connections where all the file transfers and so on could take place are encrypted with 128-bit encryption between your Windows 7 computers. So once that's all set up, I'm just going to go ahead and save the changes. And then we need to also identify the media library, what it's identified by. And I could just call mine, trainers library. I'll just call it trainers media. How about that? Trainers media. I can also identify what kind of settings I want to be available for it. So I could say all ratings are available to everybody, or only want to share anything that's rated 4 stars or higher. For example, any kind of media that I like, the songs that I like, I would only want to rate those or share those out. You can also choose parental ratings so that you could or could not choose unrated types of media to share as well. All right, now here we're looking at a different computer on the network. It has not yet joined the home group, so I want to choose home group and sharing options. Again, notice that I'm part of the home network here. So I'll choose home group and sharing options. I want to go ahead and join an existing home group, and I also want to share my own documents as well as these other items with other folks that are in that same home group. And then I'll right-click here, and I think I got it in the clipboard still. Well, maybe not. And I went offline here and put it back in there. So now I should be able to paste in that password. Now, this, by the way, takes the place of other scenarios that you would have had in previous versions of Windows. So that, for example, my username is trainer, and my password would be whatever. Okay. In the past, if I wanted to share a folder with 10 other people on the network in a work group, then I would have to create each one of those user accounts on my own local machine so that when they log on to their local machines and accessed my resources, then pass-through authentication would take place, and it would just use the credentials that they had used on their local computer on my destination network computer. The problem is, I had to create all those accounts, and if the user ever changed their password, then I would also have to change it on my copy of their local account. It got to be a huge mess. So here with home group, all we have to know is a single password. It's never really going to change unless the person who set up the home group decides to change it for some reason. And then next and finish, and now we're able to access resources on other computers. And you saw it pause there for just a moment until it made everything available, but there it is now. Now let me go ahead and get out of this, and we'll go ahead and see how we could browse for those other resources. For example, if I go to Home Group right here, notice that there's the Trainer item. We talked about the Trainer's resources. Over in the Trainer's Pictures folder, there's a photograph. This is just one I took of in Glacier National Park a few years back. And so there you go. Now we're able to share resources across the network without having to create a whole bunch of accounts that we have to administer locally. And that all use a common single password. All right, how do you resolve names on the network? Because you know how this works. When you go to access resources on a network, like if I'm in Windows Explorer right here, and I want to access a file share somewhere on one of my servers, then I might go up here and I would do a // or whack as we often call it, DC1, and then /, and then I would enter in whatever the resource is that I was interested in accessing, like the source directory, which has all of my source files in it for installations and the like. Notice that I did not enter in an IP address there. Now, I know the IP address of that server, and I could have also done that in this case. So I could do 10.10.10.10.5, source, and that would have worked just as well, okay? But in most organizations, users don't happen to have memorized the IP addresses of all the servers. In fact, a lot of times the IT department doesn't even know the IP addresses of all the servers. So it's much easier to work with names instead, because I can remember file server 1 a lot easier than I can, 128.75.22.1. Okay, so it's a lot easier. Now, if you do need to resolve a name and you just type in a name in something like Windows Explorer, or you try to map a network drive from the command line using the network, well, if it could broadcast for the name in the absence of a WINS or a DNS server. And this would be the case if you're in a home network where there's no such network server infrastructure in place. It'll just broadcast. And that's okay for very small organizations. But it only works on a single subnet. One reason for that is because if I've got a computer here on the network, and there's a router right here, and then there's another computer over here that we're trying to communicate with, well, a broadcast is blocked by routers. Okay, they do not forward on broadcasts. Only certain special kinds of broadcasts will they forward on, particularly those that relate to DHCP. So if I'm trying to access this resource over here, it will not happen on more than one subnet. However, if I'm trying to access another computer on the same subnet, then it's able to broadcast. I'm kind of sending out radio signals or sonar signals, broadcasting to this host right here. Then we could create our share and so forth, or access the share. The other thing we could do, though, would be use WINS. So if there's a WINS server, maybe this is my WINS server, which stands for Windows Internet Naming Service, although it has nothing to do with the internet. They still have the name in there. This would happen where I'm trying to broadcast, or I'm trying to find this computer over here. Let's say it's file server 1. Well, the WINS server, when it knows that I'm trying to find that, it will resolve that name for me. Okay, and it will say, oh, FS1 is on 10.10.10.7 or something like that. And then this host here will access this computer over here by its IP address. And that's actually how all network communications take place in a TCP/IP network. Even though it looks like we're connecting to a name, we're really never doing that. We're always actually connecting to its underlying IP address, and it just has to be resolved either by broadcast, by WINS, which is also going to resolve what we call NetBIOS or flat names. And then finally, there's also DNS. Now, DNS is the preferred method among all current modern Windows networks, and we're trying to kind of get away from WINS whenever we can. It's a little bit of an older kind of a standard, and it has some kind of some built-in problems. But in recent versions of Windows Server, it's better than it used to be. So some organizations will still have it. But Microsoft prefers, and most organizations would prefer, to move to DNS instead, which is the domain naming system. In terms of our concern, in terms of how to configure this for a client, really all you have to do is to make sure that you're in the appropriate location and that you've properly configured the IP address for that client. So remember, you would right-click on the network here and go to its control panel. And then you would go to Network and Sharing Center. And from here, you would just do the same configuration we looked at earlier. You would go to the adapter settings, and then you would go ahead and adjust the properties for the TCP/IP version 4 in most cases. We'll talk about 6 again here in a little while, like I said, probably in the next nugget. But here we just have to make sure that we entered in the proper IP address right here for my DNS server. That's mostly all I've got to be concerned about for the client side in making sure that I properly configure name resolution. Now let's take a look at how to troubleshoot the network if you run into any problems. One of the things you can do is just know what kind of tools are at your disposal. Probably the most common one would be ipconfig, and there are 4 different switches here that I identify that are commonly used. One of those would be ipconfig /release. This is useful if you don't want the IP address that you currently have or the IP configuration that you currently have. Maybe the IP address is fine, but the DHCP server issued a DNS server's IP address to you that has gone offline and it's not coming back. And so we reconfigured DHCP with a new DNS server address and configuration. But the clients will still have the old configuration until their lease expires, because DHCP only leases addresses for a certain period of time, and then they have to be renewed. Well, to manually release the lease, so to speak, then I would do an ipconfig /release. Then I would need to get my IP configuration again, but at this time I would want to get it fresh from the DHCP server with a new configuration, and I would do an ipconfig /renew. Now, in reality, it used to be that you always had to release first and then renew. And then starting with, I think it was actually Windows XP, Microsoft said you didn't have to do that anymore. It would be fine just to do renew, and then it would be all you needed to do. In my experience, you still have to release in order to get a reliable renewal of your IP address. Okay, so it's generally a good practice to do this one first. The other one would be registered DNS. You see, we talked about DNS earlier, and clients on a Windows network can self-register their own name and IP address in what's called an A record in the DNS server. The A record is just the main record that identifies that computer. Now, what we need to do, though, is sometimes clients don't properly register themselves because of a network interruption or someone misconfigured something or accidentally deleted A records possibly as well. Well, if you do an ipconfig /register DNS, then the client will re-register itself in DNS as long as the DNS server supports what we call dynamic update. Of course, Microsoft's DNS does support that by default. And the most common other kind of DNS server is known as a bind server, which is known as Berkeley Internet Naming Daemon, or BIND. And all current versions of BIND do support dynamic update as well, unless somebody has disabled it. And some organizations may do that because they may not like this automatic updating. There's also flush DNS. This would be very useful in a certain scenario as well. Here's how flush DNS might work for you. Here we've got a client that's trying to access resources on this file server at fs2.nuggetlab, and I just abbreviated that, .com. Well, the clients, again, they don't know the IP address for this server. So what they have to do is, when they try to access it by name, and the client doesn't know the name, then it goes to whatever its configured DNS server is, and it sends out a query to this DNS server. By the way, that takes place over UDP 53, if you need to know. I don't think you have to for the exam. That's just the fact of it. So it makes a query to this DNS server. The DNS server, if properly configured, knows that server, FS2, is on 10.10.10.2 because it's in an A record there. So it'll send the answer back to this client, and the client will then cache that A record information, that FS2 is on 10.10.10.2, in a local record, and it's usually 1 hour time to live is how long it caches it. So then it will access the resources on the file server. Now, something catastrophic happens, for example, and well, it could actually be something simple. Let's say that we had a numbering scheme change, or we realized there was a conflict with this IP address, so we changed it from .2 to .3. Well, now the client here, when it tries to access this file server the next time, it's not going to ask the DNS server for the address, even though this address probably got updated just fine. It's got the right information. This client will never know about it. Why? Because of the 1 hour time to live cache duration. It still remembers the old address, so it doesn't bother asking the DNS server, and it still tries to contact this server at .2 instead of .3. And if that happens, you'll see that it's timing out its connection attempts. Well, when that takes place, if you want to double check it, what you can do is go to the command prompt on the client, and let me just show you how that would look here. Go to the command prompt on the client and just do an ipconfig /flush DNS. And then it will flush the DNS resolver cache so that there's no longer this cached data up here. Then it will try to contact again fs2.nuggetlab.com. Then, since there's nothing in the cache, it has to requery the DNS server, and that's the value of flush DNS, is that it forces a query again on DNS. Now we get the correct address, and we can make that connection. Let's look also at netstat. This is a very useful tool for identifying open ports. Okay. Sometimes this is a security issue. You might have ports open that you didn't expect to see open, or that look strange, or that are known ports associated with hackers' tools or spyware or something like this. And so you might want to know about those open ports. You can do a -A, and that shows you all the open ports and applications associated with them. -O will show you who owns the open ports. Okay, by process ID. Okay, let me actually just show you that one real quick. Let me go over here. And I ran this a little bit earlier, so let me just clear it up a little bit. If I do a netstat hyphen, what did I just say? Oh, then that shows me who owns it by process ID. See this PID over here? That's the process ID. This tells me that the local address of this computer is 10.10.10.34, and it's got 3389 open. That's TCP port 3389. The computer that it's connected to is James Win 764 on this port number. Okay, so 3389 is the remote desktop, and as you can tell here, I'm actually using a remote desktop to make that connection. So that makes a lot of sense, and that's what I would expect to be able to see right there. Okay. Now, the other thing I can do is to identify, the process ID. And for that, I'll go to Task Manager, and you have to show processes from all users. And we can see that SVC host is port process ID 964. And so I've been able to identify which one of the hosts, which one of the applications is actually using that port. And then the other one here, -n, would just simply show you the numbers only. It wouldn't show you the translated or the resolved computer names there. Here's another tool that I really like a lot. It's called Port Query. Unfortunately, it's not included with Windows. I thought it really should have been, but it's just not. Let me show it to you. You have to download it from Microsoft. And if I kind of expand this out a little bit, this is not an exam issue. I just think it's useful information. I downloaded it and extracted it to the Port Query version 2 folder. And then you just type port QRY. And you have to choose which option you want. Mine will be local here, because I want to know the local information here. And it, again, shows me similar information, but I do find that it's much faster in how it works all of this out. Okay, so it shows me the local IP address, whether it's listening or not, and what remote port or remote host is also using it. Kind of just a little bit of a preference as opposed to netstat, but Port Query also gives you additional options. Then there's ping. This is a very useful command as well. Let me go back to this computer here and close some things up a little bit. Let's say, for example, that I'm not able to open up a web page. I clicked on my browser, I typed in the browser address, but it just wouldn't open up. So what I could do here is to make sure that I've got connectivity, first of all. I might ping my default gateway, or I might ping my local IP address. Generally, the way you do this is you work out in concentric circles, starting from your loopback address and working your way out to the destination that you're trying to access. So I do a ping, and my IP address is, I don't really know, so let's see, ping, and then 127.0.0.1 is my loopback. So this tells me that the software is working okay, the TCP/IP stack is working fine. My IP address is 10.10.10.34, so I would ping 10.10.10.34, and that tells me that I'm actually hitting my network card and it's bouncing back to me. That's working fine. Now, I want to make sure that I can contact my DNS server, so I'll do an IP, ping 10.10.10.5, which is one of the DNS servers that I have out here. That seems to be working okay. So I'll do it again, keep working myself, out into circles here. Ping my default gateway at 10.10.10.1. And then finally, I would also ping things such as I could try to ping routers out on the internet that I knew were in the middle or in that path somewhere. I can also try to ping the IP address as opposed to the host name. So for example, if I was trying to go to my own website here, let's see. That's an interesting headline. All right. Anyway, see www.hisearthmyworld.com. That's just my own website. Then when I go into this, let's say that I was not able to access it by name. In other words, I did this and it just timed out and it said it couldn't find it or something like that. But if I knew its IP address, like let's do it this way, ping ping hisearthmyworld.com. Now I know its IP address is 69.65.33.21. So if this didn't work by name, but I was able to go to HTTP followed by that IP address, then I would know that it's DNS name resolution somewhere along the line that's getting fouled up. And that's a useful tool to use for tracking down all different kinds of problems, whether it's connectivity, whether or not servers such as DNS servers are up, and so forth. You can also use traceroute and path ping, which really mostly do the same thing. Traceroute is probably more commonly used, and we've used this for a long time among old versions of Windows. Let me show you that one. And I'll just do it to the same location, www.hisearthmyworld.com. And what it does is it identifies all the hops that it has to go through, starting with my own home router, which is the Linksys item right here, and then on through my ISP until it eventually gets to the destination computer. And then it would identify that the trace is complete. It does attempt 3 different times, and using this method, I can identify if I'm having a slowdown, where I'm getting most slow speed, and that would be this one right here at 222 milliseconds, which is actually still fast, and 211 milliseconds, which again is just fine. But at least I know where the slowest points or potentially the choke points are, and maybe they're routers that are saturated with network traffic, or they could be under a denial of service attack, or who knows what else. but it's useful in identifying at least where the problems might be coming from. And I could also do a path ping to the same destination here. And this really does the same thing, except that it's a little bit more thorough and it takes a longer time to work. But it'll, again, show me all the intermediary paths that it goes through, and then it'll provide a summary towards the end that'll show you all of its results kind of towards the end instead of as it goes along. But both of those tools are very useful for identifying all the hops and potential slowdowns between a source and destination. And for general troubleshooting, Microsoft has done a really good job of working with network diagnostics. This is kind of new now with Windows 7. We've had it before in Windows Vista, but it didn't do all of the same stuff that we have now. So if I go to Control Panel here, for example, and click on Troubleshoot Problems, notice that now it gives me a number of different areas to check into. Am I having trouble with my internet connection or shared folders? A network adapter, that's very often what we'll have when we have general network problems. So I might click on that item, and then it would give me an advanced option where I could choose to also apply repairs automatically or not. I could also run as an administrator, which will give it a little bit of a deeper diagnostic and repair capability. And what this, as well as many of these other kinds of fixes, will do is they'll do things that you would normally have to do, for example, manually or from the command line, such as do an ipconfig release, a renew, the flushing of the cache. Those sorts of things might be something that a lot of these tools would do for you automatically now. You'll also want to check into general connectivity issues. Sometimes you'll go through a great deal of troubleshooting scenarios in order to only find out that the network cable was unplugged the entire time, or that someone had disabled the network card in Device Manager, or something like that. So always check the physical first and make sure that you don't have any problems there. Also check the firewall. You may not realize that a firewall was turned on. Normally, firewalls turn on automatically in current Windows products, but if you've had a third-party product in there that has disabled the Windows firewall and inserted its own, then it may also be putting up firewall rules that block ports that you didn't expect it to block. So you may need to go in there and further administer that kind of an item. Also check your routers, making sure that they are up and available. And again, you can ping them to at least make sure that they are available. And then with name resolution, you can also ping. Again, one way to ping, by the way, to do name resolution would be, let me just go back into this, a ping minus A. That would say, show me the name of 10.10.10.5. And it would return to me that the name of that computer is dc1.accusource.local. So that's one of the ways that you can use ping in conjunction with name resolution. You can also use NSLOOKUP. So for example, if I go back to that again and I do NSLOOKUP, this is a DNS tool that will identify which servers are resolving names. So if I did again, I wanted to look up set type equals, let's say, MX, and then we wanted to find out yahoo.com's MX servers. Well, now I've found out exactly what the name and IP address of all their MX servers are. From this point, maybe I could do some damage. I don't know. So anyway, this is very useful in identifying those kinds of things as well. Oops, too many clicks here. Let me bring my screen back. There we go. So NSLOOKUP is good for that. Also, double check any recent changes that have been made, such as if you changed your network from a public to a private, or from home to a public, or something like that. And that might be also the cause of some of your problems. And finally, sometimes you'll get an APIPA address. This is where the client's TCP/IP settings are set to automatic, and they would normally get an IP address from the DHCP server as usual. But instead, they're getting an IP address in this range, 169.254, dot whatever, and in a 24-bit subnet mask. This is the visual indicator to you that it was trying to get an IP address from a DHCP server, and it did not get one. This could be for a number of reasons. Number one, maybe the DHCP server just simply isn't working. The server is unavailable. Maybe the service for the DHCP server hung, and somebody needs to go back over there and restart it. It could also be that we don't have a DHCP relay or bootp. Let me show you what that's about here as well. Here, for example, I've got a client on one side of a router. That's what this is in the middle. But we're trying to get an IP address using DHCP. Well, that will use a broadcast, okay, to locate a DHCP server. But what's the job of a router? to block broadcasts, right? So therefore, it's not going to allow this broadcast to pass through the DHCP server, and I'm going to wind up with one of those APIPA addresses that I showed you about just a moment ago. So what you can do to resolve that is, a lot of routers are capable of what we call boot P, and they're designed to listen for the broadcast, known as a discover packet, by the way, discover packet, from a client looking for a DHCP server. And although it'll block all other kinds of broadcasts, if it hears a discover packet, it'll say, oh, you're trying to find a DHCP server. So, interesting inflection there. Anyway, then it will pass that packet on to the DHCP server, and it does go ahead and forward it. The DHCP server will then reply back with an offer. Okay? An offer. And it will say, hey, this is my IP configuration that I proposed for you, and the IP address I proposed for you as well. The client will hear that, and they will say, okay, I want to request to keep that offer you've given me. And then the DHCP server will say, fine, you can go ahead and have it, and it responds back with an acknowledgement. So this altogether is called discover, offer, request, acknowledgement, which you don't have to memorize, but it gives you an easy way to remember that whole process of discovery, offer, request and acknowledgement, or DORA. Anyway, it could be that if this client normally gets an IP address, but today it's not able to, and you know that the DHCP server is working, then check with this middle device, this boot P router, which could also be, by the way, it might not be a hardware router. It might be some other server that uses something called a DHCP relay agent, and that's what we see right here, a DHCP relay agent. It will do the same job as boot P and forward on those requests. Also, on the client side, it could be that the DHCP client service has failed. If you type from a command line as an administrator, net start DHCP client, then it will restart that service for you. In this nugget, we took a look at IPv4 networking. Remember, you have to understand some things about IP addressing fundamentals, primarily that it's binary based and the function of the subnet mask. Also understand and know the default classful networks and so forth. And I've got documents up on nuggetlab.com for you there. Also, we took a look at configuring network settings. This would be things such as configuring the proper IP address, the DNS server so you can get name resolution and things of this nature. We looked at network locations so that you can identify which network location you're in, whether it's public, home, work, and then again, also there's the domain, which self-configures. There's also the home group, which is allowing you to share resources on a home network where you don't have a domain to do credential authentication and things of this nature. The authentication in this case would simply be that password that I showed you. And then you can also do name resolution. This is something that, again, can take place by broadcast, WINS, or DNS, and preferably, and most of the time, it's going to be DNS. We also took a look at troubleshooting so that you can get good connectivity to your destinations. Well, I hope this has been informative for you, and I'd like to thank you for viewing.